touch on one characteristic of alkenes that I didn't touch on in the previous video when we were talking about naming alkenes and alkynes. I wanted to make a separate video for this, just to make sure that everybody does understand the concepts and doesn't get it mixed up with the naming basics. And to introduce it, just imagine butane here, just 4 carbons in a row. You can draw butane out a bunch of different ways. One way is a zigzag like this, another way where it's not a zigzag, but these two are actually still the same compound, alright, because they're still 4 carbons in a row, no matter how you arrange them. If you make something called 2-butene though, butene is an alkene with 4 carbons and a double bond in the middle. You can draw this out 2 different ways. And the reason why this is different is, in any compound with single bonds, you can freely rotate around these carbon-carbon bonds, and so that's why these two are essentially the same thing. They're just different conformations of the same molecule. But if you can't rotate around there, as you can't in alkenes, because of the pi bond here, that means this is locked in this position, and this is locked in this position. So therefore, this alkene and this alkene are actually 2 different things and 2 different compounds. Now, when you don't take into account anything else, and you just try to name both of these, you simply get the name 2-butene in each case. In each case it's 4 carbons with a double bond on carbon 2. Now everybody understands you can't have 2 different molecules having the same name. Of course not, that wouldn't make any sense. So there has to be a way to differentiate between these alkenes. These are called stereoisomers because they only differ in how these 2 groups are arranged in 3 dimensions. When you have around your double bond the groups coming off it going in opposite directions, and when I say opposite, if you think about where the double bond is and think where the methyl groups are going, here this methyl group is going up relative to the double bond, this one is going down relative to the double bond. They're going in opposite directions. On the other hand, here this one's going down and this one's going down. They're both going in the same direction, so opposite direction, same direction. When the groups are going in opposite directions around the double bond, that is called a trans alkene. So trans is opposite, cis is the same. These are going in the same direction. And when we come to draw these out, it's going to be important to be able to recognize when exactly you have a cis or a trans alkene. So for example, it says here, draw both isomers of 3-hexene. And what that means is draw the cis and trans isomers of 3-hexene. Now I'm going to start off by drawing the one that's always easier to draw, which is the trans alkene. And the reason for that is because with the trans alkene you can always keep things in a zigzag fashion. Notice how this trans alkene is drawn in a zigzag. The cis alkene is not, which makes drawing cis alkenes a little bit more complicated. So we can see hexene, 6 carbons, alkene on carbon 3. So 1, 2, 3, 4, 5, 6. There's our 6 carbons with the alkene starting on carbon 3. This is our trans 3-hexene. Now when we come to draw the cis 3-hexene, this is where we have to be careful. Okay, so we're going to go to carbons 1, 2, 3. We're going to draw on the double bond. But if we go back to the cis alkene for just a minute, for the trans alkene, you'll see one of the bonds pointed down relative to the double bond, the other one pointed up. Alright? And if I've drawn this double bond like this, with this group going up relative to the double bond, then if this is a cis alkene, this guy's got to be going up as well. So we go up and like that. So that means that these 2 groups are on the same, are going in the same direction relative to the double bond. All right. We still have 6 carbons on each side, in each molecule. It's just the only thing that's different is the orientation of the groups around the double bond. Here they're going in the same direction, here they're going in opposite directions. Alright, let's see if we can draw something out. Cis 4-methyl-3-octene. So this tells us the orientation of the double bond we're going to have. Of course, octene tells us we've got 8 carbons in our parent chain. We've got a methyl on carbon 4, and the alkene starts on 3. Now, knowing this is a cis alkene, I'm going to be careful about how I draw it out. So I'm going to go carbons 1, 2, 3. I'm going to draw out the double bond between 3 and 4. And because this is a cis alkene, I'm going to go up here. And I'm going to go, let's see, we've got carbons 1, 2, 3, 4, 5, 6. And I still have to do 7 and 8. 7 and 8. So what we've done is we've drawn that alkene in a cis conformation. The only thing we're missing is the methyl group on carbon 4, which goes somewhere like that. Okay? Alright. So here's a question for you. Here we went from a name to a structure. Let's go from a structure to a name here. So the thing to always ask first is this double bond cis or trans? Well, the way to do it, picture yourself on the double bond and then draw arrows to see in which direction the groups coming off the double bond are going. Can you see they're both pointing down? One is not up and one down. They're both pointing down relative to the double bond, which means that double bond is cis. Now, what's the longest carbon chain containing both of the double bond carbons? Well, it's going to be carbon 1, carbon 2, 3, 4. If we go here, it's 5, but we can go one longer here. That's 6. So we know our parent name is going to be hexene. We can see the double bond starts on carbon 2. Alright. Now, the cis or trans always goes right at the front of the name. Alright. So we are still going to put our substituents on, and then we put the word cis or trans right at the front. So 2-hexene, we have a methyl group on carbon 4. So we have 4-methyl-2-hexene, but we have to let the reader understand that we know this is cis. Cis refers to the alkene. It can't refer to anything else at this point. So cis-trans always goes at the front of the name. So what we've seen so far is that every double bond we draw can have either a cis or a trans designation to it. All right. Now that's true in most cases. All right. So let's just have a look at this one and see if we can figure this one out too. So look at the double bond first. We've got one group going up and one group going down. So what sort of designation for that double bond do you have? Well, it's trans. Now the other thing that gives this away is the double bond, the molecule is drawn pretty much completely in zigzag, which also tells you it's going to be trans. The longest carbon chain containing both carbons is going to be this one. And hopefully you can see we're going to start numbering from the right because we get to the alkene sooner if we do. So we've got carbon 1, 2, 3, 4, 5, 6, 7, 8, 9. So we know our name is going to be based on nonene. Now what carbon does the double bond start on? Of course that's carbon 4. Now let's look at our substituents. We've got a methyl here and an ethyl here. Remember, ethyl always comes first alphabetically, so 3-methyl, oh bollocks. Hang on. Let me try that again. 3-ethyl, 2-methyl, 4-nonene. The only other thing we're missing is the stereochemistry designation, trans. All right. Now what about if we come across a molecule like this? For all the other molecules we've seen, we can easily come up with the idea of cis or trans. All right. But when you look at this, doesn't seem to be quite as easy to do. This one looks a little different than this. You can clearly see which way the groups are going here. But how do you work this one? Well, the fact is sometimes you don't. All right. If we use this as kind of a way to figure out how we can get this one. If you look at these two methyl groups here, can you see that this methyl and this group, they're opposite to each other? But this methyl and this guy are on the same side. So does that mean that the alkene is both cis and trans? Well, no, it actually means it's neither. So the general rule of thumb is when you have an alkene where on one side of the alkene you have two of the same group, whether it's two methyls or two hydrogens, there's no possibility of cis or trans designation. That just goes out the window. So that means you just name this without cis or trans designation, which does make things easier, because now we can say carbon 1, 2, 3, 4, 5, and 6. Hexene, the alkene starts on carbon 2. There's a methyl on carbon 2, so therefore 2-methyl, 2-hexene. No cis or trans, because we can't use that when we've got two of the same group off one side of the double bond. Same thing here. There's not two methyls, but there are two hydrogens. So the alkene starts on carbon 1, and that's 2, and that's 3, that's 4, that's 5. So it's pentene, except it's going to be 1-pentene, because the alkene starts on carbon 1. The methyl is on carbon 2. So what we get is 2-methyl, 1-pentene. These are the examples where you can't use cis or trans. All right. Okay, so that's cis or trans designations for alkenes.